Welcome to my YouTube channel. This is third problem in the series of top interview 150 problems. This is in continuation with remove element problem. If you haven't solved the second problem, please go ahead and solve that, then come to this, then it would be easy to solve this. So the problem says that we are given an array and there would be some duplicates and we just have to remove the duplicates. The catch here is again the array is sorted. Now, whenever the problem says that, explicitly mentions that it is sorted, then we have to keep in mind different things. We just don't have to ignore any point which is given. And we have to return the array in the end, which is the array of unique elements. Simply, we have to return it, the length of the array in the end. So, as similar approach, we are in the last problem, we were making sure we were given a value as well. With the element, we were given a value. So in this case, we are just given an array, not a value to ignore, because there would be multiple values. Whatever duplicates value we are given, we have to ignore all of that. So in the in here also in the similar approach, we are going to use two pointer, and similarly we are in instead of ignoring the value, a particular value, we know that the array is sorted only. So in that case, we just have to check whether the array is so we just have to insert the element. In all of the cases, we have to insert the element which is not equals to its previous value. Is this as simple as that? So simply in this case, if we see, let's quickly see what happens, how this is going to work. So initially, k is equals to 1 and I is also equals to 1. We have to start from I because we have to take in consideration of the corner cases. We cannot start from 0 because we are comparing I minus 1. So it is going to throw error if we don't start from 1. So that is why we have to start I from 1. And initially k is equals to 1 because for first element we anyway have to take, and then we have to compare from the next onwards. So k is at 1. Our array looks like this initially, and k is at first position, and now we have to insert elements from here only. So at first position we can see clearly that 1 at first position it will check, and nums of 1 is equals to nums of 0. So if block is going to get ignored, and next I is going to move forward and will check whether nums of 2 is equals to nums of 2 is equals to nums of 1 or not. So clearly 2 is not equals to 1. In that case, k is going to it will come into this block, and 2 is going to get inserted. This is very similar problem this problem is very similar to the last example. So you can clearly try this problem and do dry run the second example on your own. Let me quickly show how this will work. Initially k will be at 1, and then it will, like, k will be at first position, and then clearly simply as the previous example, 0 is going to firstly get there in the array, resultant array, and 0 here, this 0 is going to get ignored. Again 1 will get inserted into the array, and both of these 1 are going to get ignored. 2 will get inserted, and then this 2 is going to get ignored. 3 will get inserted, and this 3 is going to get ignored, and then 4 will be inserted. So in the end, 0 1 2 3 4 is going to be the final answer or final array, and 5 is going to be the total length. Let's quickly write this. Let k equals to 1. We are starting k from 1 because we have to consider the first element. And also we are going to start from I equals to 1 because we have to take care of the corner cases. Nums of length I plus plus, similar to what if nums of I minus 1 is not equals to nums of I only, then we are going to insert the value nums of k plus plus. We can do simply k plus plus, or we can write and then do the increment, whatever suits. Then return the value of k. Submit the problem directly. Yeah, so this has gotten accepted. Please do dry run and try the approach, the time complexity is going to be bigger often only. Thank you for watching. Also, if you want a quick summary, we use two pointer. One pointer scans through the array, the other pointer tracks the unique element. Since the array is already sorted, duplicates are going to be at the adjacent. This is a very important point. And yeah, this is how we do it. Okay, thank you. Keep learning, keep coding.